7, we are looking at direct proportion. So I know some of you have not yet done your home-based learning. It is really your prerogative to make sure that you get your work done. Okay, so if you have not done it, make sure you get it done. Why is it a salt? Okay, so just a very quick recap about what direct proportion is. Okay, in very simple terms, we understand direct proportion as them having two variables. Okay, so having two items to be discussed. So when one thing increases, okay, the other will also increase by the same amount. So this is very simple idea of your direct proportion. Okay, it's not just about increasing. Sometimes it can also be about decreasing. So when one decreases, the other will also decrease. Okay, so one example, it can be about borrowing books in library. That is what is described in your textbook. Okay, whereby we borrow books from library and it's overdue. So if, for example, it is overdue by 1 day, you may be charged a fine of 15 cents. Okay, if it is 2 days, it will be 30 cents. Right? If it is 3 days, it will be 45 cents. And if it is 4 days, it will be 60 cents. Okay, so we see that as the number of days increase, your fine also increase as well. That is what we call direct proportion. Okay? And how we see that it is by the same amount, by proportion, okay, is that when it is an increase of 1 day, it times 2 of this 15 cents. Okay? If it is double the number of days, let's say from 2 days to 4 days, we see that the amount also doubles as well. So the increment is actually the same. And that is what we call direct proportion. Okay? To give you a non-example of direct proportion, that means something that is not direct proportion. Maybe there is this promotion at the chicken rice store. They tell you that one plate is maybe, how much is chicken rice nowadays? $3.50? $5. I don't think $5, yeah. $3.50. Okay. Then they tell you 2 plates is maybe $6. Okay. 3 plates maybe $8. Okay. I hope you are able to see that it is not a direct proportion, because when we buy 2 plates, you will expect that it is $3.50 times 2, but it isn't. Okay, it becomes $6 instead. Whereas if you want 3 plates, from $3.50, if I were to times 3 itself, I will be expecting how much? $10.50, right? But then it's actually $8. Okay, so this is not direct proportion at all. So I want us to be very clear about what is considered direct proportion and what is not direct proportion. However, I want us to be also very clear that being not direct proportion, so this one not direct proportion, or not directly proportionate, it is not the same as inverse proportion. Okay, so they are not opposite ideas. Inverse proportion in terms of a vectorial form. So let's say, for example, I want to tell you that y is directly proportional to x. Okay, I will be able to say that, or I can form an equation to say y is equal to kx, whereby k is a number to be found. So k is a constant. Later on, when we go into chapter 7.3, we are not limited to just having y and x as individual variables. I can also have another situation, let's say y squared is directly proportional to maybe x cubed. So it is entirely possible to say things like y squared is directly proportional to x cubed. And if you have such a statement, we can say that y squared is equals to k times of x cubed. Okay, so it is always about looking at what variables we're having. When it is direct proportion, we will include this constant k that multiplies with the other variable. You understand? Okay, so that is how we represent direct proportion in an algebraic manner. Okay, if I want to talk about it in a graphical sense, okay, looking at just this simple idea of y equals to kx, if I were to compare it to my straight line equation, okay, y equals to kx versus your y equals to mx plus c. How does this compare? I have a y, I also have x. Okay, I have a number in front of x because k is supposed to be a number to be found. For a linear equation, I also have a number in front of x. Okay, for which it is m. So my k over here behaves like a gradient, or rather functions as a gradient. But there is no plus c. So how we understand plus c is that it can also be a plus 0. Okay, so your y-intercept is 0. So when your y-intercept is 0, that means that in the graph sense, I will expect the straight line to pass through the origin, giving a particular gradient. I don't know what is the gradient, how steep or how gentle it is. It really depends on the value of k. Right? So it must pass through the gradient. Pass through the origin. Okay? If I have y squared is directly proportional to x cubed, unfortunately I'm not going to be plotting my graph as y and x over here. My graph will be y squared as per my variable here and x cubed. And regardless, it will always be a straight line graph that passes through the origin. B. Some of these questions are actually already covered in your SLS lesson. I just want to emphasize on the presentation. Into an algebraic equation, whereby over here I have guided you to say that when it comes to direct proportion, we will be able to get an equation that is of the format y equals to kx, because we're talking about y being directly proportional to x, right? But of course, this is not the equation that applies to this particular context. This is just a very generic form. For example, all of you, okay, before you are born, you're just either a boy or a girl. Alright, your doctor only describes you as a baby in your mother's womb. Right? Okay, so it's just a generic name. Okay, baby. Alright, boy, girl, that's all. Until you are born, okay, then your mother is able to, or rather your parents are able to give you a name. Alright, and it's specific to you. Otherwise, if you don't have this name, you're just a boy or girl. That's all. Alright? So, we want something that is specific to this situation. I need to make it unique. That means your k needs to be found. That's why I said that k needs to be found. How do we find k? We have y equals to 10 and x equals to 2. So, when x equals to 2 and y equals to 10, we place it inside the equation here, and I will get 10 equals to k times 2. Right? And then k will be equals to 10 divided by 2, which is equals to 5. Okay? It's our objective to find the value of k. In part 1, what was our objective? Define an equation. It's not to find k. So very often people tend to stop here. So I want to remind us that we are not trying to find k. We are trying to form the equation. The equation, the answer, will be y equals to 5x. Okay, so please remind yourself, answer the question. So question 1 is equation, not value of k. Alright. Next, in part 2. We want to find the value of y when x equals to 10. So we have the equation already. So when x equals to 10, we can find out what is y by replacing it into here. Replace the x with 10, and then I will be able to get the value of 15. Same thing applies to part 3. Okay, question as mentioned, y is equals to 60. So you replace the y with 60, and we find that x will be 60 divided by 5, which is 4. And that answers the question. Okay. Any questions? Right? So not all the time your direct proportion questions are being broken down into parts like this, whereby they ask you to find equation first, then after that find the respective values. There are occasions whereby you see in question 2, so if I were to erase this, when they phrase it as if y is directly proportional to x, Okay, just recognize that y is directly proportional to x. That means that y is equal to kx. Then we go and find k, because question says that when x equals to 2, y is equals to 5. So I can find the value of k to be 5 divided by 2, which is 2.5. So our equation will be y equals to 2.5x. Then we answer the question when x equals to 7. We find the value of y. And that will give us 17.5. Okay, so you can approach it in a systematic manner. Form the equation by finding the value of k, then after that substitute respectively. Which is $5,000, and then there is also a variable amount. I hope you understand what variable means. Variable means that it changes, so it's subjected to change. Unlike your fixed amount, it is confirmed that we $5,000 is part of this cost. Then there's this variable amount that is dependent on the enrollment. That means how many people are in the kindergarten itself. Where it says that per child, okay, for every child, it will contribute to the cost by an increment of $41. Okay, so we will have to add $41 per child. So if it is one child, your total monthly cost will be $5,000 plus 41. If it is two children, it will be $5,000 plus 2 times of 41. Okay? If there's 1,000 children, it will be 5,000 plus 1,000 plus 41. You get the idea? That is the total monthly cost. Okay? So in part 1, the question says that if the enrollment is 80, we want to find the total monthly cost. So when 80 children, it will be 5,000 plus 80 times 41. Right? And that will give us 8280. So that's the total monthly cost. Okay? And then in part 2, it says if the total monthly cost of running the kindergarten is $7,378, calculate the number of children. So they tell you that the total monthly cost is $7,378. How do we find the number of children? Joshua, can you tell me how many children there? Divide this by 41 directly. by two things, alright? So we need to minus away your 5,000 first, followed by dividing by 41. Okay, then that will give us the number of children at home, and that will be 58 children. Okay? Alright, just looking at part 3. Okay, I'll just finish up part 3 now, right? So part 3, a very quick one. They want you to write down the formula where C is the total monthly cost, N is the number of children. Okay? Based on this structure that we have in part 1, how do you think we can form this formula? 5,000 must be there, right? N times 41. Right? Because N is the number of children. So of course, instead of writing N times 41, we can write it as 41N. Understand? Okay? Tomorrow